So in continuation with the last microservices session that we did, which was primarily covering the microservices pattern language, one of the patterns which is of importance while we are designing microservices is in terms of decomposition or decomposing strategies or patterns. Now, typically, this deals with the different patterns that one is going to apply when you're going to design your microservices or identify the services and the operation associated with the services. Now, while you're identifying those services, there is a there's a large chance that the way you identify these services is going to directly impact your non-functional requirements in the microservice architecture, typically availability. That's one way of looking at it. And while you're decomposing the strategy, there are standard patterns which are there, and we will talk to that a little bit more in detail. The one of them is basically divide or decompose by business capability. Second is domain-driven design by subdomain method. Now, while you're decomposing these strategies, now there are typical obstacles seen during the decomposition, like maybe network latency, maybe data sharing, and what are the typical solutions which kind of help you get around that problem is something which we're going to be covering in this session. Now, the starting point for decomposition of the application into service typically happens to be from the requirement standpoint of view. So the idea is really kind of define your microservice architecture in terms of the overall software architecture concept. How do you really apply the different software architecture concept to come up with a microservice architecture? And second is define the microservice architecture from an application starting from its requirement. Because ideally, that is where you start your design process. You've been handed over with user stories or use cases, or maybe your standard SRSs. So based on that, you would be in a position to kind of start, defining or designing your microservice architecture. Now, microservice architecture. So before we kind of get into depth, we want to kind of get a recap in terms of what really architecture is, and then eventually what exactly is microservice architecture. There's a little bit of recap. So the structure, the application, and set of service. That's the whole idea in terms of microservices. And the questions which typically come to into anybody's mind: what is a service, and how important the size of service? These are very specific questions which kind of come in the way. And then there are some answers which we will talk to in terms of each of these areas. Now, software architecture is a high-level structure which consists of constituent parts and dependencies between those parts. Application architecture is about decomposing into parts, elements, and relationship between those parts. Software architecture defines the software qualities and attributes or abilities in terms of scalability, reliability, and security, and also rapid and safe delivery of the software. So this is more like a recap in terms of what is software architecture, what is application architecture, and what is the different areas from a attributes and a quality standpoint. Now, microservices architecture is an architecture style that gives an application high maintainability, testability, and deployability. Now we're getting into the question as to why should we really decompose. Now, typically in any software architecture, you are going to decompose your architecture more from a design per se into different components, because each component would ideally be handling some part of your overall functionality. I mean, that's the whole idea, because that has to be modular by nature. Now, application architecture, it's decomposing into parts and the relationship between those parts. So typically, the whole idea is that you decompose your application to different parts, and these parts interact with one another to achieve an overall business capability or functionality. Now, there could be a UI component, there could be a business component. That's more from a layered standpoint of view. And the business component could be dealing with claims management. So that's an overall component, and the claim management could actually be interacting with other components. So that kind of gives an idea in terms of what we are really talking about. And decomposing is important. Now, the whole idea of building software is to basically facilitate division of labor and knowledge. You obviously want more than one team working simultaneously together. Now, how do you get around that problem? By arriving at different parts and elements, which are kind of independent of another, and at the same time, there are well-defined relationships in between these parts. That actually kind of goes into direction in terms of how they interact and the communication which kind of comes along. So this enables multiple teams and possibly specialized knowledge to work productively together on an application. And this defines how the software interacts with one another. Now, it is decomposing into parts and relationship between those parts that determine the application's abilities. So the whole idea is that the way you decompose your application into parts, in our case, it could be services, that is what defines or determines the application abilities in terms of scalability, availability, in terms of the overall SLAs which you are going to give. So this is a very important piece. Now, going back a little bit, more into the software history side of it, we've already seen the 4+1 view, which define the four different views of the software architecture. It consists of software elements and relationship between that. So there's a logical view, there's an implementation. So the logical view is more classes and packages and relationship between them. Implementation view is what is produced in terms of build systems. It could be a jar, it could be a var, or it could be some kind of specific packaging in terms of how you want to use it. Process view is more in terms of running components. How does the system really kind of run all of it together? What's the interprocess? So basically, elements are process. The relation out here is the interprocess communication. So that's where the whole distributed architecture and design which kind of comes into play. Eventually, you have the deployment view, which processes running on a machine, and machines and processes and relationship as well from a networking standpoint. So this is like uh, an ancient age-old view which we kind of study as a part of the software engineering, principles and practices. Now, as I kind of talked about the architecture styles. Typically, family of such systems in terms of patterns of structural organization, architecture style determines the vocabulary, the component and connectors that we use in an instance of that style together with the set of constraint. The examples is layered architecture, monolithic, microservice, and hexagonal. We kind of talked about that. I'll kind of focus a little bit on hexagonal because that actually kind of gets into a direction more so from a microservices standpoint of view. Now, logical view is organized in a way that places the business logic at the center. So that's the whole idea of hexagonal is basically you have the business logic at the center. The presentation layer has one or more onboard adapters. So you can actually see on the left hand side that handles a request from the outside invoking the business logic. No data persistence layers has one or more outbound adapters that are basically invoked by business logic to invoke the external application. Business logic has one or more ports. Ports are set of defined operation and how business logic interacts. So basically, that's how the business logic typically interacts with the outside world. Inbound port, a controller that implements either a REST point or set of web pages or a message broker client. Outbound port, typically, for an example, a data access object. So this is something we've kind of talked, about hexagonal architecture, but it's just more like a recap. Now, microservice architecture is again kind of taking off a little bit back from some of the goodness of the hexagonal and then kind of really putting a twist of services on top and then kind of bringing that out. That's what microservice architecture. Monolithic architecture, architecture style that structure the implementation view in a single component, single execution. Microservice architecture and architecture style that structure the implementation view into set of multiple components and executables, where each service is a separate component. Components are service and connectors are communication protocols. So that's the whole idea. Now, each service has its own logical view, which is typically hexagonal architecture. Services in the architecture corresponds to business capabilities because a set of service or single service may is the whole idea is to kind of serve a specific business capability. Connectors in the service are implemented using inter-process communication. So that's how services collaborate together to achieve a business capability which requires more than one services. And services are likely loose coupled. So that's a Microsoft service architecture. Now the key point which is originating in this entire conversation, what is a service? And that's a question which we really want to answer. So services are independently deployable software components that implement some useful functionality or business capability. So the whole idea is that the we are going towards a direction where services can be self-contained or can be dependent on one or more services, but in collaboration they kind of achieve the overall functionality. Now, has an API. Now, how would the services really communicate with the outside world? It's obviously going to have an API, and the kind of operations which we expect the services to do are two types. Basically, command, which perform actions and updates. So basically, create, update, delete those kind of operations, and queries, which kind of retrieves the data. Now, API consists of command, query, and publishes event. So typically, the event piece is really looking in terms of how do services collaborate with another services. That's where the eventing mechanism really comes into play in terms of, let's say there's a specific service which is creating an order. Now, when the order has been created, the service needs to kind of inform other services that specifically the order has been created. This is the order number. You want to go ahead and do the next step and go ahead and do it. So in that case, the event piece in terms which kind of plays specifically from a collaboration standpoint of view. So interaction with the service happens via API, and internal implementation is completely encapsulated. So the whole idea is that the internal implementation, which is shown on the right-hand side, is completely encapsulated. Nothing gets outside. So requirement for services to be loosely coupled and to collaborate via API prohibits the service from communicating via databases. So the whole idea that earlier we had the whole monolithic application architecture where we write to database and we would communicate via database. That's can be done and dusted with. We don't have that idea here. Services persistent data are like classes in private. So if a services needs to use data, it will likely have its own private database, and that's the way we kind of leave it. Now, there's a three-step process in terms of defining a microservice architecture. The first step is to identify system operations. So typically, if you really look at most software that we build, are actually going to be taking some commands, handlers, or something. They're going to do some stuff. So the whole idea really is that, like for example, I have an order booking application from a restaurant standpoint of view. So what does it really do? It basically creates orders and accept orders at a very base functionality level. So that's essentially going into a direction in terms of what are the different system operation is the first thing which we basically start identifying from an architecture standpoint of view. Now this is, and then once you've kind of identified the operations which are actually going to get done in more so from an overall business and an functionality standpoint. The next step is obviously who's going to do these operations. It's obviously going to be the services. So a create order probably is going to be done by the order service. Now the order service in turns may talk to other service in terms of restaurant or kitchen service. That's a different part of it. An accept order typically again would be done by the kitchen service, and then obviously it'll be touching upon different areas. So that's where we identify service. Now, the third part is basically define service API and the collaboration. This is where things kind of get very interesting. You kind of define your operations, you define your services. Now, in order to basically get the overall business functionality work, there is a chance that a single service may collaborate with one or more services. So that's the whole idea in terms of, you can actually see once you create an order, it basically then verifies the order and then creates a ticket on the kitchen service, and eventually you can accept an order in terms of the next step. So this three different steps which you need to remind yourself and remember. Identify system operation. Once you kind of define the operations, identify the services which are actually going to be doing those operations, and third is basically defining the services and APIs more from a collaboration standpoint. It's a very simple process, not too complicated, but just a point which I need to make out here is specifically this is an iterative process. Okay, it cannot be followed mechanically. The whole idea is it's something which will evolve over a period of time, and this is deeply ingrained in terms of different software design principles, which I'll kind of talk a little bit more. Now, the first step is obviously in terms of defining your we're going a little digging a little deeper in terms of defining your applications microservice architecture. The first step is basically identifying your system operation. So the whole idea is starts off with defining a high level domain model. I mean, the idea is that you take your requirements, you identify the different classes which are there, which kind of participate together to kind of do the overall functionality. So this kind of goes back to the software design principles in terms of identifying nouns as users and verbs as operations. So I mean, this is where we kind of define our class designs. I mean, very standard object oriented analysis and design principles which are applicable are here to how to come up with a high level domain model. Next thing is basically you have a system operations. So basically each of the classes are going to be doing something. They're either going to be updating data, they're going to be retrieving data. So that's where the system operation, and the way to identify system operation in your user stories, look for verbs. Nothing too complicated. Third is behavior of each command is defined in terms of an abstract domain model. Fourth is system operations become the scenario that illustrates how services collaborate. So basically that's eventual, it kind of leads to in terms of how services really collapse. So now identifying system operations, typically we have two different patterns, which kind of we talked in terms of microservices architecture pattern language. The first one is decomposed by business capability. Now this is something which we would be doing any which ways. And if you don't follow an object-oriented analysis design approach, we go with the business capability, where we look at, we look at each business capability and define that as a specific entity of some sort, which is, for example, the capability of an insurance company is underwriting, claims management, billing, and compliance. So I've kind of broken down the overall things in terms of business capability. Now, business capabilities are identified by looking at the organization's purpose, structure, and business process. So again, this is like a business, domain-driven design approach, where you basically look at business capability and then kind of define in terms of what are the different areas which a business is supposed to come together to kind of really build the software. Now, each business capability can be thought of a service. So, like in this case, a supplier management could be one service, consumer management could be one. Now, its specification consists of various components, including inputs, outputs, and SLA. So, supply management, the whole idea is that the supply management has to do everything to deal with supply management. So the courier management piece, the restaurant information management piece, everything. So it's all encompassing, and it consists of components including inputs, outputs. So basically, supplier management is going to be talking to the components. So that's how we kind of take the business capabilities and identify them as services, and eventually the collaboration around that is more from a inputs and outputs standpoint of view in terms of how it's actually going to collab. For example, input to an insurance underwriting capability is a consumer application inputs of are approval and price. So that's where you kind of start detailing out in terms of what each service is going to take from an input standpoint and what is expected from an output standpoint. Business capabilities focus on particular business object. For example, claims business objects is focused on claims management capability, claims review, and claims payment management. So the whole idea here is you kind of decompose your overall design in terms of business capabilities, where each business capability ends up being a service. And the whole idea is that there's no tight coupling between those services. I mean, that's more from a design perspective. So when you're looking at things in terms of there has to be they should be loosely coupled, per se. And then eventually the next pattern which we're going to talk in terms of identify is decomposed by subdomain pattern. So, a domain-driven design has been around for some time. Typically, it's centered around the object-oriented domain, and the domain model is mirrored in design and implementation. So, what you build from a domain standpoint with different classes eventually kind of flow into design and implementation. You're going to see those corresponding classes. There's a traceability. Now, domain-driven design is different from traditional approaches from the software modeling, which has a single model for the overall enterprise. So, typically, in object-oriented analysis and design, from monolithic architecture standpoint of view, we see that the overall model or the domain that we build is a single model for the entire enterprise. But the approach in domain driven is a little different. Here we are taking basically a single definition for each business entity, customer, and order. Now, obviously, there are going to be problem associated with that. With domain driven design is trying to get an agreement on a single domain across the organization. It's going to be complicated. Moreover, different parts of the organization, the same term or different concepts for different concepts or different terms for the same concept. So there's going to be some kind of confusion in terms of there's an account object which is an order. What should the attribute really be? And similarly, there's an account object in the account subdomain that could be a lot more lot more elaborate. It could have all the properties dealing with accounts. So the question is which one is right? Now, domain-driven design defines separate domains for each subdomain. Subdomains are identified using the same approach for identifying business capability and operation. So the whole idea is that an account class which happens to be in order is specific to the order subdomain, and an account class which happens to be as a part of accounting subdomain is in the realms of an accounting subdomain. We define boundaries. That's what we kind of come up with the context. So that kind of solves the problem of having two separate account classes, one in the order subdomain, another in the accounting subdomain, and both can continue to live because there's a boundary across that, because you kind of define a boundary. And that's so for all required discussions, account in the account class and account subdomain would ideally have 200 different attributes, and the account and the order domain would probably have about 50. So both of them are correct because they are be defined by boundaries, and that's what the boundaries which we call as a context out. It's a bounded context. The bounded context includes code artifacts and implement the model. Now each bounded context is a service or a set of services. So that's how the whole definition of services really come up at a in a DDD with a subdomain standpoint of view. So it kind of solves for the problem by allowing classes to have different definition across different subdomains. So that's one way. So this is a problem typically we've seen in software design. If we have one big model, there are chances where the model can end up having classes which are extremely relevant, because you come across situations in certain business processes. I don't want to use the 300 different 200 different attributes for a specific account. I may just need 3 or 4 or maybe 20. So what do I do? So that's where the conversation really this is the method by trying to solve for these problems by the subdomain pattern. Now, as we kind of decompose, there are some guidelines. Now we kind of coming down to, so think of it like each business capability that we build ends up being a package, and each package is going to have several different classes working together to achieve the overall functionality. So package principle is a way of organizing classes in a larger system. This they help in understanding which classes should go into a package. That's what we call as package cohesion, and how should these packages interact with one another. That's what we call as package coupling. Think of package as a service. So eventually that kind of become the unit of deployment as well. So typically once there are certain decomposition guidelines. So one of them is common closure principle, which is applied at a service level or a package level. What it states is that it's basically a package cohesion, which states package should not have one or more reason to change. This helps in identifying classes that are likely to change and package them together for the same reason. And if classes are tightly coupled, they are all in the same package. This is a standard design guideline, nothing too complicated. Something which you need to keep in mind, that obviously you want to try to keep all those classes into the package which are relevant to one another, and the reason for change is going to be one. And so this kind of makes sure that if a package A changes, you don't kind of end up changing 10 more packages. Single responsibility principle. This is more applied at a class level. So SRP kind of states that every class in a package should have a well-defined responsibility over a single part of the business functionality. This is how we kind of define the different classes in terms of the basically let's say the ledger management classes, in terms of what each of those classes is really going to do. So each of them have a defined responsibility, and the class should have only one reason to change. Now, decomposing of business capability or decomposing by business capability or DTD, along with SRP and CCC, are good techniques for decomposing an application into services. Now, in order to apply them successfully, you need to solve for transaction and inter-process communication. These are things which we will, in the subsequent session, we kind of talk more in terms of when one service is kind of dependent on more than one service, and there is obviously a data sharing across the services, and what is standard inter-process communication which needs to be followed. Now, typical obstacles which one is actually going to be seeing while decomposing this application, as you kind of go about designing your different services, these are certain things to kind of watch out. Obviously, there are solutions around this. So network latency is a very standard one which you see. So basically, let's say a particular decomposition into a service may result into many round trips between services. Now, usually this is a symptom which we see in most deployments after we've deployed the entire thing. We kind of figured out, oh, the service we deployed has a dependency on X and Y Z services, and then eventually, the round trip of these services kind of, introduce network latency, and the services are running fairly slow. Now, there are methods to reduce the latency by implementing batch API or fetching multiple objects in a single round. So it's like the chatty calls versus one call. Now, in some solution, the idea of combining services, replacing expensive IPC with a language level method call, is also an alternative. But that's again, it's more from a case to case basis which are relevant. But there are ways to solve the problem. Now, second thing which is kind of which is very visible on the table is basically a lot of the service external APIs are running as REST-based services, and they tend to be synchronous by nature. Synchronous inter-process communication reduces availability. Now, how to implement inter-process communication which does not reduce availability is the key. REST protocol usage is favorite among developers. REST reduces availability, use of asynchronous messages, elements time coupling, and improve. So again, as we kind of talk about the inter-process communication, we'll talk a little bit more onto that. That's a separate session. Maintaining data consistency across services. Now, because some services needs to update data in multiple services. Now, this is a unique problem. Now, use of Saga patterns in session 4, which we talk about transaction in microservices, will cover these solutions. Now, obtaining a consistent view of data. Monoliths generally are blessed with one large model and one database and one package. Obviously there are going to be benefits in terms of having asset based transaction guarantee that a query will return the consistent view of data. Methods to solve is going to be coming in terms of upcoming sessions. Now got classes like we talked of the account class class, which kind of in a single domain will end up being extremely inflated, will be a very bloated class. Now, as we talked about, the domain driven design with subdomain kind of helps us to a certain extent. So next, obviously, we kind of come to a point of defining services API. You got your operations, you have your services. Now, service API operation exists for one of the two reasons. Some operation corresponds to system operation, they're invoked by external client and perhaps by other services. Other operations exist for collaborating between services. These operations are only invoked by other services. The services API publishes events to collaborate. Now, again, depending on the design, you may take different approaches. Session on transaction and implementing queries in microservice covers how events can be used to update GQRS view. Now, we'll kind of get to this a little bit more in detail once we kind of get onto the session, which is specifically dealing with transaction and basically implementing queries in microservices. Now, the starting point of defining services is to map system operation to service, determining APIs required to support collaboration between services. Some system operations span multiple servers and need a different design approach and data and in-process communication standpoint of view. These are some of the areas which we'll have to be dealing with upcoming sessions. What are the key walkaways in this session? Architecture determines your application's abilities, including maintainability, testability, and deployability, where which directly impact the developer development velocity. Microservice architecture, the architecture style gives high maintainability, testability, and deployment. Service and microservice architecture are organized around business concerns, business capability, or subdomain rather than technical concerns. Two patterns of decomposition we should talked about: decomposed by business capability, decomposed by subdomain. Eliminating god classes, which we've seen typically in the bloated classes, which we talk in terms of how domain driven design really talks about that. Now with that, now for if you have more questions, please reach out to me at this email address, and the PPT and the session of the video can be found on this URL. Thank you for the session.